Good evening. My name is Jaskirat Singh Sudan, and my topic is contrastive learning with Siamese neural network. So, I am trying to do similarity learning with this. What similarity learning is basically, we'll have two images and we'll create embeddings of those two images. So, like each image will have its own embedding, and then we'll compare these two embeddings. So the idea is similar images should have same embeddings or similar embeddings, and dissimilar images will have different embeddings. So I'm using Sammy's network architecture to create these embeddings, which is like we'll have two neural networks which are identical neural networks to make these embeddings. So the dataset I am using is MNIST 100 digit dataset. So this is the architecture of Siamese neural network. First, we'll have in this diagram, you can see we have two images and then two neural networks. These are identical, and then they share weights, which means obviously they are identical, so they have same weight for now. And then each image will have these neural networks will create image embeddings, which is 128 dimensional embedding vector. So then we'll find the distance between these embeddings. So this is like 128 dimensional vectors. So in 128 dimension, we'll find how far these embeddings are from each other. So as I said, the idea is to ideally same similar images. So like all the zeros should be very close. Their embedding should be very close to each other, and all the ones should have their embeddings very close to each other. But for 0 and 1, their embedding should be as very far. So that's the idea. So I'm using Euclidean distance. So it will compare these two embeddings for same similar images. Will have the distance as 0, which means they are very tightly they are in a cluster. And for dissimilar different images, will have distance more than 1, or for this case more than 0.5, because I'm using sigmoid in the last layer, so it will kind of cut off from zero point 0.5. So if the distance is more than zero point 0.5, that means that they are different pairs. Yeah. So for this I am using contrastive loss function. So like this is the formula for contrastive loss function. um, and this is the training procedure. And so yeah, MNIST dataset I'm using 60,000 training and 10,000 for testing images. Optimizer is RMS probe, and I have tested it with different epochs as well. I've mentioned all the things in my um report. And batch sizes I have also tested with different batch sizes. So the performance I'm getting is like roughly 98% validation accuracy. And yeah, so this is what I was talking about. In all, I have reduced the dimension through PCA. So I've used PCA to reduce the dimension so that I can plot it in three-dimensional space. So I'll show you the working, but this is like each color is like different digit. So like these all digits, these are the embeddings, so they are arranged in a cluster with similar clusters. Similar images will have their own cluster like this. And oh, and yeah, so I have made a GUI also to test the model. I'll up I I'll add the GitHub link in my report as well. So um, this is the like GUI. You can load the model, and you can load two images. You can compare the images, and you can classify one image. And you can also see the embeddings plot. How are these embeddings located in 3D space? So the conclusion is, I have successfully demonstrated this digit similarity learning using contrastive loss with this Siamese neural network. And what this embedding space is useful is it enables us to for zero shot or few shot learning scenarios. So we don't have to train for new data, new images. We can just use the embeddings. And also these embeddings, if you, for MNIST, uh, in future cases is for, I've only used it for MNIST, which is like very basic data set. But if you have good data for like ImageNet and all, although those data set requires big models, but the idea is, if you have that embeddings of these images and if you have embeddings of words, then you can fuse those embeddings and then you can do so many things with just the embeddings if you have a model which can create good embeddings of these images. Yeah, so I'll show you the code. So this I used this script for training. So I created, this is the model architecture. I also mentioned this in my report. This is the training, and you can see the gradual decline in loss function. And yeah, so I'll show you the implementation now. Yeah, so this is the GUI. Now we can load the model from here. So I'll load this model, and then we can load images. So I have images here. So it's like um, all the images in I have 20 images, I think, per class. Yeah. So let's see, we'll load maybe one, and we'll load three. So we know, okay, first of all, let's try classification problem. So classify image one, which is this one. It should be one. So predicted digit one. That's correct. But we know that these numbers are different. Okay. So in when I hit compare, so it is showing distance is more than 0.5, which is 1.82, which is similarity. No, they are not similar. Okay. So we'll test again. We'll put 0. It's not similar. Let's try 1. Okay. So these are similar images. Okay. We'll try 6. And this 6. Okay, these are similar. Let's try 6 and 0. They are not similar. So that's the idea. So this point is like I'm creating a graph. So if it's like it's rendering 100 points in the graph. So I can, let's increase it to, oh, sorry, 4,000 points. And then we can see the graph. Yeah, so this is the graph. So as you can see, this is digit 8. Okay. So I've we are getting these lines, these straight lines. The reason is I've used PCA to reduce the dimension, right? So it might be possible that these okay, so what is this? This 3 and 0. It might be possible that they are they are clustered in a single dimension, in some higher dimensions. That's why uh, when I used PCA, they are coming in a line. But these, we can see, although we have some noise, but we can see they have made a cluster, like 6 have its cluster, this is 7's cluster, like this is 3 cluster, then this is 5 cluster, and then this is 8 cluster, this is 9 cluster, and same way this is 4 cluster. So yeah, this was my project. I'll say the reason I made this project is I've been inspired by um, few of the work which has been going on in this direction. So there are something called energy based models. So this approach is one example of energy based models. And there are, I read several research papers from Meta which talks about these energy based models and more human like AI. So the idea is with these approaches, Siamese network and contrastive learning and energy based models, we can make these models understand the image better rather than just relying on probabilistic model, which is the usually what which is how usually we'll target classification problems. So that was my project. Thank you.